your goal while watching this video is to be able to calculate the percent that a quantity has changed. So when you calculate a percent of change, so envision going to the store, finding a pair of shoes you love, and they're 20 bucks. And then going back a week later, and there's a big sign that says clearance, they're on sale, now they're only 15 bucks. What percent did the price change? That's what we're going to be calculating in this section. So to find the percent of change, you take the amount that a quantity changed, either increased or decreased, and you divide it by the original amount. Remember, fraction bar always means divide. So in the case of the shoes we just talked about, the price changed $5, and you'd be dividing it by the original price, which was $20. Okay, so our first example is dealing with hours that you spend online. So on Saturday, you spend 2 hours online. On Sunday, you spend 4.5 hours online. What is the percent of change in your online time from Saturday to Sunday? All right, so Saturday to Sunday, we're starting at Saturday, we're going at Sunday, or going to Sunday, so we can tell right away that your time increased or decreased? Increased. So we're looking for a percent of increase. What percent did your time increase? And going back to the slide, we know that we need to take the amount of change divided by the original amount. So we are going to substitute those two things with their values. So my amount of change, if I look at that, I was online 2 hours on Saturday, 4.5 hours on Sunday, so that gets me 2.5 hours. All right, the difference is 2.5 hours. 4.5 minus 2 is 2.5, so my amount of change is 2.5. And that should always be a positive number. So even if you're going down, even if you had spent only a half an hour on Sunday, you should still have a positive number as your amount of change. So you'll always take the bigger number minus the smallest number to find your amount of change. Then we're going to divide by the original amount, all right, or your first amount, which was Saturday, which is 2 hours. Okay, so 2.5 and divide it by 2. Write down your percentage, or write down the decimal that you get. All right, now on your calculator, when it spat out that answer, it probably didn't have a percent sign on it. So we need to turn that into a percent, and you can't just plop a percent on it. Remember, to go from a decimal to a percent, you're moving that decimal 2 places to the right. So 125% is the amount that our number of hours in line changed by, and it's an increase. So 125% increase in the amount of time you spent online this weekend. Okay, another example. Bar graph shows a softball player's home run totals per year. What was the percent of change from 2012 to 2013? All right, so first thing we can look at, we're going from 2012 to 2013. In this case, it was a decrease. Their number of home runs decreased, so we know we're looking for a percent decrease. But again, what we do is we take the amount of change divided by the original amount, or the first amount. So in this case, my amount of change for the bigger number, the bigger quantity minus the smaller quantity, is 8. And the original amount, or the first amount we had in 2012, is 28. So if I would take 8 divided by 28, I get this number, and I'm going to round it to the nearest hundredth. All right. Again, when my calculator spits out that number, it doesn't have a percent sign on it. So in order to go from a decimal to a percent, we're going to move that decimal 2 places to the right, and we'll get 29%. And in this case, from 2012 to 2013, we went down, so it's a 29% decrease. In this person's number of home runs. Last example, finding a percent error. This is very similar to finding percent of change. So here's what we're going to do. You estimate that the length of your classroom is 16 feet. The actual length is 21 feet. Find the percent error. And percent error we do use a lot because there are a lot of things we estimate first and then we go back and find the actual measurement later. So I estimate estimate the length of my classroom is 16 feet, actual length is 21 feet. Find the percent error. To find the percent error, we take the amount of the error. So how much were we off by? When we estimated, how much did we over or underestimate? In this case, we estimated 16, the actual length is 21, so we were off by 5 feet. So our error amount equals 5 feet. Okay, and then we're going to divide it by the actual amount. So how long is my classroom actually? It's actually 21 feet. So in this case, we're just carrying out the division. Remember, every fraction is a division problem just waiting to happen. 5 divided by 21 gives us rounded 24 hundredths, or 24%. Okay, so we had a 24% error in calculating the length of our classroom.